In this video, we will learn how to calculate an average rate. If we have data of concentration versus time, either a plot like we see here or a data table like we'll use in the example, we can calculate the average rate over any two data points. And we do this by calculating the slope over that interval. Now, rate is defined as a change in concentration over time. So it will have units of concentration over time, such as molarity per second. Importantly, if we're looking at reactant concentration as it changes over time, then like this plot shows, that concentration will be decreasing and the slope over any 2 points will be negative. Rate is always shown as a positive value, so to get the rate, we take the negative slope, and for our two data points, slope will be y2 minus y1 over x2 minus x1. Now it's worth mentioning how we get the units of rate, because it's not magic. It comes from our slope because slope has units. I'll let that sink in for a bit because this tends to be tricky to grasp. Slope has units. We'll revisit this idea multiple times over our study of kinetics. But here's the thing. It's super easy to figure out what they are. Because we calculate slope as change in y over change in x, our units of slope will be y units over x units. Here, the y units are molarity and the x units are seconds, and our units of rate will end up being molarity per second. To solve this type of problem, we'll first identify our two data points. These could be the beginning point and the end point, which would give us the average rate over the entire experiment. It could be the beginning point and some other point, which gives us the rate near the beginning of the experiment, or it could be any two data points in the middle of the range. Then I suggest writing out the equation for rate using only variables first, like I show here, before entering the values. This will remind you of what the slope equation is and that when we're using reactant concentration, we need to take the negative slope. After you enter the values into this form of the equation, then you're ready to do the math. To do the calculation, perform each subtraction first, the numerator and the denominator, and round each part to the fewest decimal places. Remember, that's our rule for sig figs when we're doing subtraction. Then the final division step will be rounded to the fewest sig figs based on the results in the numerator and the denominator. And then you'll report the rate with the proper units and sig figs. So let's go ahead and identify the two data points that we'll be using. We have 60 seconds and 120 seconds. So the 60 seconds will be our x1, y1, and the 120 seconds will be our x2, y2. And in this case, our x value is time, and our y value is concentration. Now we'll write out the equation. It's really not a waste of time to do this to make sure that you get, again, the right values in the right places. So rate is going to be negative m, and our slope is y2 minus y1 over x2 minus x1. One of the most common mistakes here is to forget the negative sign. So we'll plug in our values. So rate equals negative y2, which is 0.0720, minus y1, 0.1019, divided by x2, which is 120.0, minus x1, 60.0. Now I didn't include the units here. Let me go ahead and just add those on. So our y units are molarity, and our x units are seconds. So the tricky part here is generally not the math. The math is pretty straightforward. The tricky part tends to be keeping track of the sig figs. So that's why I recommend dealing with the numerator and its sig figs, dealing with the denominator and its sig figs, and then combine to do the division. If you want to keep some extra digits, you can. Just make sure you're marking where the sig figs are properly based on the math. So for our numerator, just keeping track here, before we do the math, we're going to count decimal places because it's subtraction. So notice that each value has 4 decimal places. So I'll just make a note up above. So once we do the math, we need to retain 4 decimal places. In the denominator, we only have 1 decimal place in each of our values. Our rate then, we're just now going to get our numerator and our denominator, and I'll incorporate the negative sign into the numerator so then I don't have to deal with that anymore. So we have 0.0720 minus 0.1019, and taking the negative of that, rounded to 4 decimal places, gives us 0.0299. And we keep the units of molarity. That's our 4 decimal places. Doing the math in the denominator, 120.0 minus 60.0, rounded to 1 decimal place, gives us 60.0 seconds. So now, because we're going to do division, we want to count the sig figs that we have based on the subtraction. So in the numerator, we have 3 sig figs. In the denominator, we also have 3 sig figs. So that means that our final result, after we do the division, will be rounded to 3 sig figs. So doing the math, 0.0299 divided by 60.0, rounded to 3 sig figs, gives us 4.98 times 10 to the negative 4, and I'm out of room here, but my units are molarity divided by seconds, and I can report that as molarity times seconds to the negative 1.